Hi, good afternoon to all the students. Yeah, how is everyone? Today is a hot day again. So I hope everyone has a good fan or have open your aircon or air cooler. So because today is one of the hottest day for this year again. Okay, for today, I will be letting you to do the presentation as we already planned for it. So who wants to do presentation first? Which group want to start first? Yeah, you do let me know. I will just let you to present. Yeah, may I know who, which group want to do first? So 28 of you already joined. Yeah? So many of you are your friends are ready to listen to your presentation. Ernest and Paul Jingwen. Okay, sure. So I will leave the stage to you. Yeah, let me stop presenting.
Sir, can you hear me clearly?
Your voice is a bit soft.
A bit soft. How about now?
Yeah. How about the other? Can you listen to? I think okay lah. Yeah, now okay. Yeah.
I can. Yep.
Yes. So I will leave the stage to you. So presentation is about 10 minutes. After that, your friends can ask you question. So thank you very much. So we welcome Ernest, Ng Jie, and also Paul Jingwen to discuss about the ARM processor. Thank you.
Okay, thank you, Dr. Hong. Hi, a very good afternoon to Dr. Hong and my fellow classmates. My name is Ernest Ng Zijie, and today, me and Mr. Paul Jingwen will be presenting the ARM processor. ARM is an acronym for Advanced Reason Machines. Given its name, the ARM processors are based on the Reduced Instruction Set Computing Architecture, which is a computer architecture design that uses a small, highly optimized, and simple set of machine instructions that can be executed within one clock cycle. The history of ARM started in 1978 as Acorn Computer Limited in UK. In October 1983, Acorn launched the Acorn RISC machine project to develop their own RISC processor. In April 1985, ARM1 has been introduced as the world's first ARM processor. And a few years later, ARM2 and ARM3 were introduced as the successor of ARM1. In 1990, Advanced RISC Machine Limited was founded as a joint venture between Acorn Group, Apple Computer, and VLSI Technology. In 1991, ARM6 was introduced, and with the adaptation of ARM6 in the Apple Newton PDA, has greatly increased the popularity of ARM processors. In 1998, the company changed its name to ARM Limited, and its parent company, ARM Holdings, floated on the London Stock Exchange and the Nasdaq. And after that, ARM went through multiple acquisitions, and finally, in 2016, ARM Limited has acquired by SoftBank Group. Today, due to high performance, lower power consumption, and freedom for customization, ARM processors are extensively used in consumer electronic devices such as smartphones and wearables. Apart from consumer electronics, the ARM processor is also powering the world's fastest supercomputer as of March 2021, which is known as the Fugaku, powered by Fujitsu 48-core A64FX ARM-based processor. To ease the comparison, we will compare two Samsung Exynos ARM-based processors. The reason to choose the two processors is that both are flagship processors, with Exynos 5410 introduced in 2013 and Exynos 2100 introduced in 2021. As we can see that the Exynos 5410 is using the ARM version 7A profile instruction set architecture with 32-bit word size. The processing architecture is the ARM big liter with 4 high performance core. The Cortex A15 combined with 4 power efficient core, the Cortex A7. It has 8 cores and 8 threads, 2 MB cache memory, fabricated based on the 28 nanometer HKMG process, having a dual channel LPDDR3 RAM with maximum memory capacity of 2 GB, using the eMMC 5.0 storage type, ARM generic interrupt controller version 2, and the EMBA 4 bus interface. On the other hand, the Exynos 2100 is using the ARM version 8.2A profile ISA with 64-bit word size. The processing architecture is the ARM dynamic big liter with 1 custom core, which is the Cortex X1, 3 performance core, the Cortex A78, and 4 power efficient core, which is the Cortex A55. It is also having 8 cores and 8 threads, 4 MB of cache memory, fabricated based on the 5 nanometer Samsung LPE EUV process, quad-channel LPDDR5 RAM with maximum memory capacity of 16 GB, UFS 3.1 storage type, and ARM generic interrupt controller version 4 and the EMBA 5 bus interface. This diagram shows the changes of the ISA from version 5 to version 8. The features that added to the version 8 is the introduction of AH32 and AH64 execution state. The AH32 state supports the A32 and T32 instruction sets that use 32-bit registers for processing, and the AH64 supports the A64 instruction set that use the 64-bit register for processing. With the introduction of the two states, it allows 32-bit application to run in a 64-bit OS, and 32-bit OS to run alongside under the AH64 hypervisor. In short, the ARM version 8A profile extends the old architecture while maintaining backward compatibility in AH32. Next will be the processing architecture. What is so special about ARM big liter and dynamic big liter processing architecture? The big liter technology is a heterogeneous processing architecture that combines 2 different processors together in an SoC. With the big processor designed for maximum computing performance and the small processor designed for optimal efficiency. The big liter technology will dynamically allocate workload to the processors accordingly, based on the processing intensity required for that particular workload in achieving the most efficient power envelope, fulfilling the high performance demand and long battery life at the same time. While the dynamic big liter is an improvement to big liter that can support up to 8 big and liter cores in a single cluster. With a dynamic shared unit bridges all cores and cache memories together to ease communication. It can support cores that have different microarchitecture, implementation, cache configurations, and frequencies. This technology offers wider range of possible configurations or combinations of big and little cores to meet the unique needs of application. On the new dynamic multiprocessor design, each core will have a private L2 cache and a shared L3 cache for every cluster, delivering higher performance, efficiency, and the possibility in optimizing the design. That's all for me. Next, I will pass the stage to Mr. Paul Jingwen to carry on the presentation. Thank you.
So thank you, Ernest, on the presentation just now. So I'm Paul Jingwen, and good afternoon, sir, and everyone. So now I'm going to continue with the presentation on the memory of that is supported by both of the processors. So basically, as in the comparison table just now, so there is for Exynos for 5410, it will be the processor supports the LPDDR3 RAM, while for Exynos 2100, the processor supports the LPDDR5 RAM. So the LPDDR RAM is actually means that is a double rate data rate synchronous dynamic random access memory, while the low LP stands for the low power consumption compared to the to its counterparts. So this type of RAM is more suitable for mobile and automotive applications that require high performance with low consumption. So the right hand side, the LPDDR5 standard is actually a fifth generation of the technology, which is published by JEDEC on 19 February 2009, while the LPDDR3 is the third generation, but also published by JEDEC in May 2012. So as you can see, from the as time improves, you can see the data rate has improved from LPDDR3, which is data rate which is 1600 or 2133 megabytes per second to 6400 megabytes per second. So as same as the other specs, the prefetch size is increased by twice. The I/O bus clock frequency increased nearly thrice, while number of banks while retaining compatibility on the while still having 4, 8, and 6 and in the LPDDR5 RAM. So for voltage wise, you can see that the power consumption is getting lower as although the maximum is 1.8 volts, but the next spec is 1.05, which compared to the LPDDR3, which is 1.2 volts. So the burst length is also doubled or even quadrupled, while the command address bus size it will be increased too. So for internal storage interface, as mentioned also in the comparison table, so there is eMMC, which is the embedded multimedia card standard, and also the UFS3 for Exynos 2100. So the eMMC is a multimedia card standard internal storage format introduced by Multimedia Card Association in 1997. So which is comprised of a controller and a NAND flash memory within a single integrated circuit. So this standard in the internal storage format is more commonly used in smartphone, tablets, and also laptops due to its cheaper cost and small size. While the UFS, which is a universal flash storage, is a flash storage standard published by JEDEC, which offers a significantly higher bandwidth compared to the eMMC standard, while using the same amount of power. The version is being used, the version 3.1 is announced by JEDEC in January 2020, and it's also the latest version and is being used in the Exynos 2100. So as you can see from here, the standard, the transition of the standard, which is very improving from the bottom to the top. So you can see the speed gradually increase a lot since throughout the years. As also the write speed, the random read. While the random read and the random write speed is actually not, the IOPS unit is actually the input output operations per second. So of course, throughout the time, all of them has great improvements. So the next one will be the interrupt system of our processors. So as mentioned just now, the interrupt system is controlled by the generic interrupt controller of the processor. So so the ARM generic interrupt controller is a block of interrupt priorities blocks that carries out interrupt management, prioritization, and routing to boost the efficiency of the processor and supports the virtualization of interrupt. So the ARM GIC has evolved from version 1 to the latest version known as GIC 4, which is, as mentioned, implemented in the Exynos 2100. So the GIC that is used in Exynos 5410 is known as the ARM Core Link GIC 400, which is using a GIC v2 architecture. It carries out interrupt detection, management, and also virtualization for the ARM version 7 architecture processor, which with up to 8 cores and 480 shared interrupt configurations. So while the GIC4 is implemented in the Exynos 2100, which is based on GIC v4. So the architecture is built on top of the GIC v3, the previous version, that offers support for much higher interrupt counts and larger number of processors. Besides that, the GIC v3 has also supported more than 8 processing elements which is greater than the GIC v2. So on the GIC v4 architecture, the only more changes is actually the direct injection of virtual interrupts of ARM Cortex A3X MP core. So for the I/O interfaces, the the I/O interface, the ARM bar is used, which is the ARM Advanced Microcontroller Bus Architecture. It is an open standard used to outline the connection and management of different components or blocks within the SoC. So this specification has become a standard that has been widely applied in the interfacing of components within the SoC, with ARM 5 as the latest revision of this architecture. In ARM 5, ARM introduces coherent hub interface or CHI architecture, defining the interface for the full connection of fully coherent processors and high performance interconnects. ARM 5 also introduces the XC5, ACE5, and also AHB5 protocols, which extend prior generations to include a number of performance and scalability features to align with the to align and complement the coherent hub interface. So as you can see from the diagram, there's a lot of specifications here: the ARM CHI, ARM ACE, ARM AXI, AHB, and also APB. So that throughout the generations, there is more improvements in the ARM system. So there's improvements. Yeah. So as a conclusion, basically, so in the quadrant 4 of year 2020, so ARM reported that a record of 6.7 billion ARM-based chips has been shipped to its silicon partners in the prior quarter, equivalent to 842 chips shipped per second. So to date, ARM has a total of 1,910 licenses and 530 licensees, with more than 180 billion ARM-based chips were already shipped by its silicon partners. So ARM processors, as a conclusion, ARM processors stand out because of its smaller size, reduced complexity, low power consumption, and also low heat dissipation characteristics. It is extensively being applied on increasingly miniaturized devices such as smartphones and wearables. As of 2019, ARM has a market share of 90% for mobile and mobile and IoT application processors, and 75% market share for the in-vehicle infotainment and driver assistant applications. Despite of its overwhelming advantage of ARM processors in mobile processors market, the CISC-based processors are still dominating the server market, which is what Intel is good in. So recently, notable rivaling of ARM processors against the desktop class x86 architecture processors can be seen, such as the Server X Pro, announced by Microsoft with custom SQ1 ARM-based processors developed together with Qualcomm in 2019, and the implementation of ARM-based Apple M1 processor into the MacBook in 2020. So it is an undeniable fact that ARM processor is making its way.
10 minutes already, long past already. Yeah, for Jingwen, please finish up. Yeah, because we have other groups. Thank you.
Okay, so I guess that's all. Yeah, it's okay.
Okay, thank you, Ernest and also Jingwen for presenting the ARM processor and very informative information about Samsung Exynos 2100, and also we know that it's using a 5 nanometer. May I know, do you know what is a system on chip design? Can you roughly explain what is SoC or system on chip? Yeah.
Yeah, Dr. Hong. The system on chip device is basically a small chip that contains the CPU, the GPU, the memory, and the and the other things together combined together as a system. So it's actually an integrated circuit that integrates all the components of a computer to work on a miniaturized device because just a small IC. So the IC is already like our motherboard. So when it is, of course, it has another separate motherboard. So the SoC is actually being soldered on the motherboard and function as a system as a whole. I mean, whole system consists of the CPU and GPU, the graphic
Yeah,
processor.
okay.
Yeah.
So thank you for your explanation. So this is about system on chip. And you can see that many of the manufacturers have already fabricated 5 nanometers IC, right? According to Ernest and also Jingwen presentation. So I think Intel will follow soon. Yeah, so thank you for your presentation. Any other things, other members? Yeah. May I know any other question? If no question, then thank you very much to Ernest and Jingwen for your wonderful presentation. So yeah, thank you and yeah, let's pass to the next. Yeah, thank you. Yeah, thank you. Next, we will invite Dreamin and also Wen Yang to continue for the presentation. Are you ready, Dreamin and Wen Yang? Yan Chang and Sherwin, I'm not sure whether we have time for your presentation because we have already spent about half an hour. So if not, then you have to postpone you to next week. Yeah, sorry for that. Yeah. The stage is yours. Dreamin and Wen Yang. Thank you.
Thank you, Dr. Hong. Can you see my slide?
Yes. Yeah.
Okay.
Your voice is clear as well. So
Okay.
don't worry.
Okay, I will start my presentation now. So good afternoon to Dr. Hong and my fellow classmate. I'm Lu Zumin and my partner is Lim Wen Yang. Today we would like to present about the Intel and also the AMD processor. So first of all, let's introduce about Intel. Intel was founded on 18th of July 1968 by the semiconductor pioneers Robert Noyce and also Gordon Moore, who had left Fairchild Semiconductor. Before calling name as Intel, it was originally called NM Electronics. Intel Corporation considered as the largest semiconductor chips manufacturer in the world and the developer of the 86 series microprocessor. It has dominated the market of PC chips processor by created its own CPU brands such as Intel Quad, Intel Atom, Celeron, Pentium, etc. Besides, Intel also involved in autonomous cars and small low-power devices as wide range of solutions, which is targeting the data center, wireless, networking, military, medical, and also industrial market segments. So moving on to the AMD, which is so-called Advanced Micro Devices, it was founded on 1st of May 1969. At first, AMD collaborated with other semiconductor manufacturers, International Business Machine Corporation, which is IBM, and Motorola to co-develop production technologies and manufacture its own processors at company-owned semiconductor foundries. AMD also have a few Guinness World Record achievements of highest frequency of a computer processor. The main products of AMD include microprocessors, embedded processors, graphic processor, and motherboard chipsets for embedded system application, as well as personal computers and workstations and also servers. So for the Intel i7 series, I would like to talk about the i7 8086K and also i7 8700K. As you can see from the table, the lithography are same, which is 14 nanometer. Core stress, thermal design, power, and others characteristics are also same, except for the frequency. You can see that the base frequency for i7 8086K having 4 GHz, while which is higher than the 3.7 gigahertz of the i7-8700K. Maximum turbo frequency for i7-86K can even go up to the 5 gigahertz, while i7-8700K is slightly lower, which is 4.7 gigahertz. Moving on to the Ryzen 3000 series, I would like to discuss about the Ryzen 3800 XT and also Ryzen 7 3700X. FinF50 having same, which is 7 nanometer, and also core and threads are both 8 and 16 respectively. But when it goes to the frequency, Ryzen 7 3800 XT are a bit higher than Ryzen 7 3700X, which is 3.9 gigahertz. Maximum turbo frequency for the Ryzen 7 3800 XT can even go until 4.7 gigahertz. It is a bit higher, but the Ryzen 7 3700X could only achieve 4.4 gigahertz. Although having the lower frequency, 3700X still having lower thermal design power, which is 65 watts compared to the 105 watts for 3800 XT. Memory types is DDR4 and the maximum temperature is 95 degrees Celsius for both. So now I would like to pass to my teammate Lim Wen-yang to discuss about the comparison between the Ryzen 3800 XT and also Intel Core i7-8086K. Thank you.
Good afternoon, Dr. Hong. Can you hear my voice?
Yes, I can hear your voice. Yeah.
Now I would like to talk about the comparison. Since the release of Ryzen series, AMD have become the biggest competitors of Intel, and these two manufacturers have been battling it out in the component arena for years, with newer internal that are more powerful than ever rolling out from either side. It is harder to pick the best processor from one of the companies because both sides are releasing better and better components faster. So the AMD Ryzen 7 3800 XT is chosen to compare with the Intel Core i7 8086K, which both chipsets are similar and targeted the same high-end performance market. From the table below, we can see that the AMD Ryzen has the advantage of, because it released it released more frequently. Next. Yeah, from the table below, we also can see that the Intel Core i7 having the advantage which consume up to 10% less energy than the Ryzen 7 and has 6% higher turbo boost frequency. While the advantages of AMD Ryzen 7 includes it has 20 MB larger L3 kit size and having around 15% higher theoretical bandwidth. Next. In this table below, we can see that the AMD Ryzen 7 having the advantage of with more modern manufacturing process and has 2 more physical cores. Next. Then both tables show that the benchmark score and the rating score for both chipsets. Both of the benchmark shows that both processors having a minor difference in single core performance, but AMD Ryzen 7 has outrun the Intel Core i7 both multi-core performance, which has 72% higher performance in Cinebench R20 and 19% higher performance in Geekbench 5. The result in multi-core performance for the both chips having a huge difference because multi-core processor is invented to overcome the processing time of the executing instructions, which means that when the number of the core of the processor is higher, the performance when multitasking under the demands of programs and applications that require higher RAM usage is higher. The difference in power efficiency score of electricity consumption between two processors also having a huge difference because both processors using different fabrication process, which Intel Core i7 uses 14 nanometer technology while the AMD Ryzen using 7 nanometer technology. The reduced size in the AMD processor will bring around the advantages on reducing heat, TDP, power consumption, and density of identical design from other companies. Based on the result above, with the advantages of more modern manufacturing process and has 2 more physical cores, AMD Ryzen 3800 XT outrun the performance score when compared to Intel Core i7. Therefore, in this comparison, AMD Ryzen 3800 XT is a better processor no matter in performance or power efficiency. That's all from us. Thank you.
Thank you for your presentation. You already claimed that AMD Ryzen is actually performing better than Intel i7, right? Yeah. So may I ask a question? So in your opinion, if you want to use your computer to do some homework, so which type of computers will you which type of computer will you be using? Will you use the one with i7 processor or AMD Ryzen processor? Which one is your favorites?
If compared with these two chips, I will prefer the AMD chip because it's much cheaper and the performance is better.
Okay. Yeah. Okay. Thank you for your explanation. How about Jimmy?
For me, I will also having the same opinion with Wen Yang, because as a student, we don't have much of the income. So compare like this, the AMD are having a cheaper, and also we just need it for the homework things that may not need such a quality performance too. But within the comparison, also the AMD are having a better performance. So I think the AMD is better.
Yeah. Okay. Good. Very good. Thank you. Just now also we already listened to beside this AMD we also listen to ARM processor. Basically in our daily life we are either using ARM with our using our handphone, and also Intel or AMD. What else we use? For those who can afford a better computer, maybe they will buy Apple, right? Yeah. So those are the processor that we use. So thank you very much. So I think we thank you very much for 4 presenters for today. We still can proceed, I think. But please make your presentation, Yan Chang and Sherwin. Please make your presentation within 10 minutes because I also need to ask you some questions. So I will leave the stage to you. Thank you. Yeah. Sorry, because today quite rushed because I have another class afterwards. Yeah. Thank you.
Okay, a very good morning, a very good afternoon to all the students and Dr. Hong. Today, me and Sherwin will be presenting the ARM processor. Next. Okay, move on to the introductions. Why ARM processor called ARM? This is because ARM processor is developed by Advanced RISC Machine, ARM. The features of ARM processor is using RISC architecture, which means reduced instruction sets computer, and this architecture helps in perform a smaller number types of computer instructions. With that, the processor can operate at a higher speed and with more than millions of instructions per second. Thus, it called as the MIPS architecture, MIPS performance. Another features is that ARM processor mostly operate at single cycle execution and is save power. Next. Okay, up until today, there are many cores designed by third parties implement the ARM instruction sets, such as the famous company, Intel company, AMD, Qualcomm, Samsung, Apple, and many more. For example, the X-Scale core family manufactured by Intel. They implement the ARM architecture version 5 instruction sets. Under the X-Scale, it comprises several distinct families, such as IXP, IXC, IOP, and the one shown in here, the PXA family processor. Next is the Snapdragon core designed by Qualcomm, which is the processor used in our phone nowadays. An example is the model MSM8260, which implement the ARM architecture version 7 instruction sets, and its microarchitecture is called Scorpion. Next is the AX core family designed by Apple company that is mostly, but not all, implement the ARM architecture version 8 instruction sets. Besides that, the Tegra model T132, aka Tegra 2, aka Tegra K1, designed by NVIDIA, also implement the ARM architecture version 8 instruction sets. The Optron series of processors under K12 core family also designed by AMD using the ARM v8A instruction set architecture. Last but not least, the Samsung company. The Exynos core family is designed using ARM v8A instruction set architecture. Next. Next. Move into the history of ARM processor. The history of ARM processor begins with the first ARM processor, the ARM1, which is created by Sophie Wilson in 1983 and is fabricated in 1985 using VLSI technology's 3 micrometers process. And it has the features of 808 lines code, 24,800 transistor, 25 register, and using 26-bit address space. After they use ARM1, they found out that the processor hardware cannot use multiply and can only do the multiplication using software, which is very slow. And ARM1 also cannot support coprocessor. Thus, they come out a solution, the ARM2. The ARM2 processor is fabricated in 1986, a year later, using the micrometer CMOS processor, using 2 micrometer CMOS process and with 2 additional register, in total 27 register. ARM2 processor can now support hardware multiplication and accumulate. Next, after the invention of ARM2, the performance is still not fast enough. They don't want to use the DRAM chip as this will make the product more expensive, and thus they come out the solution by opt to integrating cache inside the CPU. With that, the ARM3 is built in a L1 cache with 4 kilobytes per core run in 64-way set associative, and is now 3 times faster than the ARM2. The ARM3 is fabricated in 1989, implemented on a 1.5 micrometer CMOS process, much more smaller than the previous one. ARM3 achieved 3 times the performance with the help of integrated circuit, integrated cache, integrated clock generator, integrated control logic, and integrated core processor interface. Then when the cache is being designed into the CPU, they found out that there's a problem that no one handle the memory and caching operation. From here, they come out the ARM6 with virtual memory with integrated MMU. So MMU is the...
You still have 5 minutes, yeah? This rush up, thank you.
Okay, memory management unit. Basically, it store the memory reference and help it in performing the translation of virtual memory address to physical address. ARM6 is designed in year 1991 with 0.8 micrometer process and changed to 32-byte address space from the previous one, 36-bit. The evolution is still going on with ARM7, 8, 9, 10, 11, and then secure core, Cortex M, Cortex R, Cortex A, and the latest, the newest core family. Next, I will pass the stage to my best friend, Xuewen, to present the comparison of ARM-based processor. Thank you.
Thank you, Yan Zhang. So my name is Pang Xuewen, and I'll be presenting the comparison among ARM-based processor. So first, I would like to introduce the ARM Cortex A76 microarchitecture, which was introduced in 2018. It has out-of-order superscalar execution, and it can power up to 3.3 GHz of max clock rates. is used to develop the Kirin 980 and Cairo 485 and Cairo 495. Eventually, Cairo 485 are used to build the Snapdragon 855. Now that the Snapdragon is used to build with Cairo 485, we can compare using Snapdragon 855 with Intel i7 8086K. So from the first line of the table, you can compare that the Intel i7 have different manufacturing size compared to Snapdragon 855, which is 40 nanometers and 7 nanometers respectively. Each of the transistor counts, which Intel i7 has 3 billions, where Snapdragon 855 has 6.7 billion transistor count, including those not part of the CPU chip, as it is a system on chip. Moving on, the instruction set architecture which Intel use are x86-64, whereas Snapdragon 855 uses ARM 8.2-A ISA. The most important thing of CPU processor are the cores. So Intel i7 has 6 cores. Simple 6 core, nothing special. Whereas Snapdragon have a complicated 3 clusters of CPU cores, having a total of 8 CPU cores, which can be divided into 2, which is 4 Cairo 485 silver core based on ARM Cortex A55, whereas the other is Cairo 485 gold based on ARM Cortex A76. The subsequent is the cache. So the cache is listed as the table like as below, but as you can see, just based on L3, Intel i7 can having a larger cache compared to Snapdragon, where L3 has 12 megabyte of cache and where Snapdragon have 82 megabyte only. Moving on to clocks, Intel i7 have a base frequency of 4 GHz, whereas it can reach a max level of 5 GHz. Whereas Snapdragon have 3 different clocks running not after 3 GHz. From now, we can easily decide that which processor are capable to processing faster. The Intel i7 should be able to compute faster compared to Snapdragon as it has a larger cache and a higher clock rates, although the cores are lesser compared to Snapdragons. Intel i7 and Snapdragon do also have their each Intel integrated graphic processor, which are Intel UHD Graphics 6330 and Adreno 640 GPU. Moving on, we'll be comparing the Intel i7 8086K with Snapdragon 855. We are in the terms of the microarchitecture layout. So this is the microarchitecture layout which has L1 and L2 cache, private L1 and L2 cache, same as the A76 ARM Cortex A76, which has their private L1 and L2 cache, and then we have a shared L3 cache with 12 megabyte for Intel i7, whereas the L3 cache for ARM only have here in this case for Snapdragon we only have 2 megabyte. Moving on, this is the die diagram, die illustration diagram for the each Intel i7, and this will be for the Snapdragon. So you can see the area that occupies for CPU cores this portion only for Cairo 485, combining both silver and gold, where Intel i7 has the center portion, almost half of the portion for the 6 cores, as Snapdragon is a system on chip consisting others chip for other function for the mobile devices mostly. Okay, in conclusion, In conclusion, both processors have its own advantage, and thus both processors have applied in different scenarios, such as Intel i7 are for desktops, where Snapdragon 855 are for mobile devices. Our recommendation for each processor companies is to reduce their manufacturing sizes to 5 nanometers and optimize its architecture as much as possible. And that is all from us. Thank you.
Thank you very much to Yan Chang and also Sherwin for presenting this informative presentation. So you have already discussed about the ARM processor together with many of the types of the ARM processors like Snapdragon. Do you know which brand of handphone actually is using this Snapdragon 855? Can you list out some of the examples? Sherwin?
855, I'm not sure, but 865, currently I'm using 865, which is Oppo.
Oppo using 865.
The reason I chose 8.
Okay. Which other brands?
Huawei Nova 7 SE 5G, the newest, also use the Snapdragon 855.
Oh, I see. So many of the handphones are actually using Snapdragon.
Yeah, Realme X7 Pro 5G also use.
What is the company that produce Snapdragon?
Qualcomm.
Okay, Qualcomm.
Qualcomm.
Okay. Actually, Xiaomi also using this. Xiaomi also using this Snapdragon X65. Yeah. For the high-end one. High-end. Because there are many different types. They have the Snapdragon has a 6 series, which is cheaper. After that, got 7 series. 765 series is the middle range. After that, the highest range is this Snapdragon 800 something. So this one will be quite expensive. Maybe 1,500 to 2,000 ringgit Malaysia. Yeah. So I think many of our phone manufacturers also using Snapdragon. It's a very famous processors. So may I know okay, this you said that this Cairo is actually used by Snapdragon to build up their chip, right?
Yeah.
Cairo, Okay.
Cairo 485.
So I also noticed that actually the number of transistors in Snapdragon is actually higher than Intel i7. Yeah, why is that happen?
I think it's because part of the transistor are responsible for the other chip, which is so go back to which the DSP of the chip such as Hexagon 650 if not mistaken.
So I would like to ask Jingwen. Is Jingwen online? If you compare your processor Samsung Exynos 2100 and then this Snapdragon, which one should be better? Jingwen, are you still online? Because I think you haven't answered my question. Yeah. Jingwen, are you online?
Sir,
yeah.
I'm Ernest, same group with Jingwen.
Yeah, Jingwen is not online.
I think he's having some internet connection issue.
Oh, okay. So you
I will
answer on
answer
behalf
this
of him.
question on behalf of him.
How about Exynos 2100 and this?
Sir, because just now you are mentioning the Snapdragon 855, right?
Yeah.
855 is actually introduced in 3 years ago, and it's actually using in the Galaxy S10 series, while the Exynos 2100 is the latest one introduced in 2021 using in the Samsung Galaxy S21 series. So by this comparison, I will say that Exynos 2100 is
Better.
as having a higher performance. But however, the Snapdragon processor is known famously for its power efficiency than the Exynos, although they are using the same, almost the same fabrication process. So
But your processor is actually having 5 nanometer, yeah? 5
no,
nanometer processor.
yeah, 5 nanometer, but because the Exynos 2100 having a custom core, the ARM Cortex X1, so this core is actually they have the freedom to customize the frequency and all these things. So Qualcomm seems to have a higher capability in customizing this frequency so that they can achieve higher power efficiency than Samsung. Yeah.
Okay, thank you for your explanation. Meaning that all of you are very familiar with all those processors, handphone processors. Okay, thank you very much. So today we have 6 persons have already presented. We have Ernest Ng, we have Po Jing Wen, we have Lu Juimin, we have Lim Wen Yang, we have So Yan Chia, and also Peng Xuewen. So thank you for your presentation. We still have 2 groups coming in on next Tuesday. So are you ready? 2 other groups. Yeah. So please present on next Tuesday. So I think we will call it a day for now. If you have any question, you can contact me through the WhatsApp group, okay, or WhatsApp me. So if there's no question, then we will call it a day. So thank you very much for your presentation. I hope you can learn from all the presenters for today. So thank you very much. So I will end the class today if you have no more questions. Thank you.